So I've got the fundamental theorem of calculus part 1 in the top right corner. Basically what's happening is we're asked to find a derivative of an antiderivative, right? Because the integral asks us to evaluate the antiderivative as part of its calculation. So those are going to cancel each other out in a way. Just make sure to replace your limit of integration in here for t, okay? And then also use the chain rule. So the derivative, I'm trying to take dydx of this part, so that cancels out the integral symbol. And instead of t, I'm putting x to the third. But remember that t was being squared. But then I also need to multiply this result by 3x squared because of the chain rule. Then we can clean that up a little bit. So I'll put the 3x squared out front. And then this is e to the x to the 6th power, because powers on top of powers multiply. And there we go. We're done with this one up here. So we'll do something similar down here. Remember, this is like your a in the first part of the fundamental theorem of calculus. Okay, so a isn't going to factor in at all when we take the derivative with respect to x. So we're trying to take a derivative with respect to x of an antiderivative. So those cancel out. The derivative and this integral symbol, it's like they cancel out. But just make sure to go through and plug in 3x everywhere where you see the variable of integration, everywhere where you see the u. And then don't forget about the chain rule. The derivative of 3x is 3. So the 3's can cancel here. And then I can simplify inside the radical. That's 9x squared all over x. There we go.